So as we look about implicit differentiation, we need to discuss what is an implicit equation and what is an explicit equation. If I have y equals 5x cubed plus 6x squared plus 2, this is an implicit, this is an explicit form of the equation. This is an explicit form. We solved for y. You can solve for y. Your equation is written explicitly when you solve for y. Now, if we have y equals 1 over x, this is an explicit equation. But the same equation could be named by x times y equals 1. And this is the implicit form. Implicit form occurs when we have not solved explicitly for y. And most of the time, every time that we have found a derivative so far this year, we have found a derivative from the explicit form of the equation. We've taken the derivative of y with respect to x. And in each case, we're taking derivatives, and we've only taken the derivative of the variable x if we're finding with respect to x, or t if the equation was in t instead of x. Right? But there are times when we cannot explicitly solve the equation. For instance, let me move this up just a little bit. If we had x squared minus 2y cubed plus 4y minus 6 equals 0. Can you solve that equation for y?
Absolutely. Yep.
Absolutely. How would you do it, Michelle? What would you do to solve it for y? Okay, I'm going to stop recording for just... If it were possible to solve that for y, and maybe you can. Ms. Roundtree may be able to do that, but I can't do that. So we need to find another way to find the derivative. We have always found a derivative so far explicitly when we have explicitly solved for y. Now we're going to look at how we can find the derivative when an equation is in this form, when it is in an implicit form. And this is called implicit differentiation. Right? So we're going to be looking at implicit differentiation. It's very, very similar to what we've done. In fact, if we say, let's say that y equals x cubed. If I want to find dy dx, in other words, I'm going to take the derivative of y with respect to x. Another way I could write this is taking the derivative of x cubed, because that's what y is with respect to x. And what is that? 3x squared. And really, we have taken the derivative of x. We never showed it before, but really what we've been doing is taking the derivative of x with respect to x. And what is dx over dx? 1. All right? So whenever we're taking the derivative of x, an x term with respect to x, we really are doing the chain rule and saying times dx dx, which is just 1. Andrew, you have a question?
I can solve for y for any given x squared.
Not without a calculator.
No.
And we're not using a calculator. So, thank you for your input, but I didn't mean to burst your bubble, but we're not going to use a calculator here. And it's probably available to be done some way, but without a calculator, and I'm not even sure with a calculator how you could do it. But
There's a function.
is there?
Yeah.
Okay. All right, let's move this up. And look at what we would do if we want to take the derivative with respect to x of y cubed. So this time, my variable's not x, but we're taking it with respect to x. So we really are using a form of the chain rule. We're going to take the derivative of y cubed, which is 3y squared, and then we have to take the derivative of y with respect to x. So your answer here is 3y squared dy dx.
Wait, so we take the derivative of what?
You take it's kind of like using the chain rule. The derivative of the outer function, which is the cube, times the derivative of the inner function, the derivative of y is dy dx. So if we wanted to take the derivative with respect to x of x plus 3y, well, the derivative of x with respect to x is 1, and really dx over dx, but that's just 1, so we don't even have to put it. Plus, what's the derivative of 3y? 3 dy dx. So any time that you are taking the derivative of y with respect to x, it's followed with dy dx. Okay, well, haven't been recording, but this is for Rachel's benefit, and she can see what I've already put up there.
Wait, so she can hear anything we're saying?
Yes, she can.
Hi, Rachel.
All right. So collect all terms with dy dx on the left side.
Where is Rachel?
She's doing a college
Where's Rachel?
visit. With dy dx on the left. Enough. And everything else on the right.
Does it say width? Is that W width?
Yes.
Are you sure?
Yes. Everything else on the right. Move this out of the way.
But shouldn't there be a little slash for width?
There is a slash.
No. That W right next to the dy dx. Term W dy dx.
Oh.
Yeah, what's that W there for?
Joey, you know what I'm talking about.
I don't. I didn't know if it was a new variable or what you were doing there.
If you listened when I said it, you would know what I was doing there. All right. Factor out dy dx on the left.
It's about to go down. It's about to go down, people.
Are you talking about your grade?
My grades are too good.
I could probably fix that. And then finally, solve for dy dx. Okay, so the first thing, you differentiate both sides of the equation with respect to x. Collect all dy dx terms on the left, everything else on the right. Factor out the dy dx, and then solve for dy dx. All right, so our equation is y cubed plus y squared minus 5y minus x squared equals -4. And I want to find dy dx. So, Sam, what's the first step?
Differentiate both sides.
Differentiate both sides with respect to x. So this becomes y cubed becomes what?
3y squared.
3y squared dy dx plus 2y dy dx minus 5, yes, dy dx minus 2x equals 0. All right, next step is to derivative of a constant is always 0. All right, so now we have to add 2x to both sides. And I have 3y squared dy dx plus 2y dy dx minus 5 dy dx equals 2x. You could have combined the second and the third step right here. This would have been easy enough because now we do what? Ryan, what's next? Factor what?
dy dx.
Okay, so if I factor out a dy dx, I'm left with, and so now if I solve for dy dx,
It's gonna be 2x over 3y squared plus 2y minus 5.
we get 2x over 3y squared plus 2y minus 5. So if possible, we want to rewrite y as a differentiable function of x. So if we have x squared plus y squared equals 0, could we rewrite this explicitly? Could we solve this for y?
Yes.
Yes?
Y is equal to square root of.
Okay, so first you'd have to do what?
Well, it'd be like y is equal to.
Would that be
You can't have a
negative?
negative.
Is that possible?
No.
No.
You can't have a negative.
Because x squared is going to be positive, and you can't have a negative x squared. So we can't rewrite this. What do you think this would look like graphically?
An upside down.
Let's think about this. This looks like the equation x squared plus y squared equals r squared is the equation of what?
Circle
A circle with radius
of whatever R is.
r.
So
Okay,
this would be
so
the
if
point.
this has a 0,
It'd be a point kind of because the circle would be so infinitesimally small.
okay, so this really would just look like this. Graphically, you just have a point. All right, let's think about x squared plus y squared equals 1.
We have a point at 1. I don't know. I mean, it'd be like a point at work.
Okay, this is actually the graph of a unit circle. All right, so if we were going to graph that, well, actually, if we're going to solve it explicitly, we'd have y squared equals 1 minus x squared. So y equals plus or minus the square root of 1 minus x squared. The positive part would give us the upper half. That's a function. This is a function. And so when we put them together, we no longer have a function. We have a circle, which is not a function. But what can you tell me about the slope at the points 1 and negative 1?
It's 0.
It's the slope 0?
It's a horizontal asymptote.
Vertical.
Or not
Yeah,
asymptote.
vertical tangent
Tangent
line.
line, yeah.
So the slope is undefined when x is 1 or negative 1. All right, we didn't even have to take the derivative to figure that out. If we can look at the graph, we could easily see there that at the point 1 and negative 1, you'd have a vertical tangent line. And so at the points 1 and negative 1, the derivative is undefined. And you could only take the upper half or the lower half there. All right, let's think about, change that up just a little bit, the equation. Let's look at x plus y squared equals 1. All right, if we solve this for y, we get y equals plus or minus the square root of 1 minus x. What is that going to look like? What would the other half look like? half a parabola turned on its side. Okay, now let's think about this. Where is it going to intersect the x-axis when x is 1? Is it going to open to the left or to the right?
To the
To the
right.
right. I know, to the left because it's a negative x.
Okay, in one way, okay, say, okay, I'm not sure. What could you do to determine? If you didn't have your calculator, we're not using
Oh,
calculators.
because 1 minus 2 would be a negative number, and you can't take the square root of a negative
Okay,
number.
so you could just plug in another number just to see which way is it gonna, open.
can't
If you
hear that.
plug in a 0, you'd have the square root of 1, which is 1. So the upper half looks like this, and the lower half would look like this. What happens to the tangent when x is 1, or the derivative when x is 1?
It's undefined.
It's undefined. All right? And then finally, let's look at x squared plus y squared equals negative 4. What can you tell me about that equation?
Is it like the same as the one that we had at the top that like
Michelle, what can you tell me about that equation? X squared plus y squared equals negative 4. A circle.
Sorry.
What, Andrew?
It would be circle, only.
it'd be like a
What's an inverted circle?
A circle.
oval, right? Like
That's
the
a circle.
well, you don't call it that. You call
All
it.
right, look at that equation. X squared plus y squared equals negative 4.
It's not possible.
Why is it not possible,
It's
Ryan?
gonna be a hyperbola.
It can't be negative 4.
It looks like-
square root of a negative 4.
Is that what-
And you cannot add two squares together. We're dealing with real numbers here. You cannot add two
squares can't be
squares and get a negative number. That's a no solution. There's no solution that would make that a true statement. Okay, so no solution would make that a true statement. All right, you have your assignment.